In this video, we're going to be covering a lot of ground, and we're going to start with some basic area formulas that you should already be familiar with. So first is the triangle. Area is equal to 1/2 times base, where base is generally the horizontal piece, and height is from the base to the opposite vertice at 90 degrees. Then we have area of a rectangle. Is sometimes written as base times height. As you see here, it is a length times width. I prefer to use the base times height formula, and just a little note that base and height are always connected by a right angle. So if we stick with that, then all we have to do is identify where the right angles are, and we just have our bases and heights easily identified. Now, a square, I'm going to leave as side squared. But essentially, one side is its base, the other side is its height. It is connected by 90 degrees. So I suppose you could say area is equal to base squared. Sometimes the letter choice is just semantics. All of that should just be simply review. Now let's start with your basic rectangle. And let's shave this piece off over here. And let's add it on over here. And what do we have? We have ourselves a parallelogram. So if we started out with a rectangle and area is equal to your base times height, all we did is we moved this piece and put it over here. So have we changed the area, or is the area still the same as this? It's the same. So area is still base times height. But where is the height? It has to meet the base at 90 degrees. So this is going to be our base, and this is our height. And what are we looking for again? The 90-degree angle. Now, what about the trapezoid? Well, we'll start with our little trapezoid right here. And what we're going to do is we're going to duplicate it. So what I've done is I've drawn one in blue. And I'm just going to move it over here, and I'm going to rotate it around. Now, in a perfect world, this little area right here would be a nice little seam. And so what do we have? Well, we had a base down here. We'll call this base 1. And then parallel to this base is our other base. We're going to call that base 2. Now base 2 on the blue one is on the bottom because it's upside down, and base 1 is on the top. And really, what is this thing? It's just a gigantic parallelogram. And we said that the area of a parallelogram is base times height. Well, again, we don't have a height figure in here, so let's just drop one in at 90 degrees. There's our height. So the area of this doubled figure would be base times height. But what is the actual length of the base? It comprises of, or consists of, base 1 added to base 2. And then I'm going to take that and I'm going to multiply it by my height. The problem is, if I get that area, I have the area of 2 trapezoids, and I really just want the area of the one original. So I'll divide it by 2, or multiply by half. There's our derivation of the trapezoid formula. And as for the circle, we won't get into it, but there are reasons why area is equal to pi times radius squared. So there's our base 1, base 2, and our heights. There's our base times height for parallelogram, trapezoid, and circle. So now we're all set. We brought along our triangle, rectangle, and square. And now we're going to use these 6 formulas to kind of tinker around a little bit. Now, before we get going, we want to have a process. So let's talk about some steps to solving the area of any figure. First, you have to decide what the figure is. Maybe it's a square. Maybe it's a triangle. Maybe it's a triangle and a square. Maybe it's an ice cream cone, right? A triangle and a circle. All right, so we're going to have to think. Identify formulas that you need. So the area of a triangle and the area of a circle, or the area of just a square, the area of a triangle and the area of a rectangle, whatever it is. Substitute in the values that they give you. You may have to do some math to figure out some of the missing figures that go in these formulas. Maybe not everything's going to be given to you. And last, finish out the arithmetic, probably with a calculator. And remember, area is 2-dimensional. So when you're finished, it's always some answer with units squared, centimeters squared, feet squared, right? Because area is two-dimensional. You probably want to write this down. In this video, I'm not going to do all the problems all the way through. I'm just going to get you far enough, and you're going to have to finish things and figure things out a little bit for yourself. I'm just going to guide you along. Now, what do we have here? This looks like a trapezoid, right? So that's my step one. Step two, the area formula for a trapezoid is 1/2 times base 1 plus base 2 times the height. And what's next? Substitute in known figures. So here's base 1, it's 27, plus base 2. These guys are parallel, 19. Close that, times my height. Height meets base at 90 degrees. That's how I know that that is the height. All right, is there anything missing? No. Okay, let's go grab the calculator and finish this out. First, we're going to add the 27 and 19 because it's in parentheses, and then we'll go ahead and we'll deal with the multiplication. So I get that that's 46, and then you'll want to finish out the multiplication, and then don't forget to label this with a centimeter squared, but you finish. And I'm going to be checking this for credit, so you're going to want to make sure that you actually do finish these problems. Next, we have ourselves a triangle. Now, the dotted figure out here, this is not part of the area. The area is all in here. And so there's a value here that we are not going to use, this diagonal, or fancy word, oblique piece of the triangle. So first off, it's a triangle. Next, I know that area is equal to 1/2 times base times height. Next, I'm going to substitute in the pertinent information. Here's my base, so that's 29.5. And again, the height goes from the opposite of base. So we extend the base out and go 90 degrees to the opposite vertex, which is right here. And so this is our height. So that's times 14. You say, well, what about the 37.2? Not useful for the area, useful for the perimeter. So go ahead, finish this one out, and remember that is in square inches. Now what do we have? This looks like a semicircle. So fancy for half of a circle. Area formula for a circle is pi r squared, and since we only have half of a circle, then I guess we'll take half of it, right? Divide it by 2. So area equals 1/2 times pi r squared. Either way, whatever one floats your boat. I prefer the one I circled. So now I'm going to substitute in the pertinent information. 3.14 times radius looks like 17. And that radius is going to be squared. And I'm going to divide that all by 2. And so what do we do first? First, we're going to square it, right? Because in PEMDAS, I see an exponent, so I'm going to do that first. Then I see multiplication, I'm going to do that second. And then I have division, and I'm going to do that third. Multiplication doesn't always come before division, but in this case, we're going to take care of the top part of the fraction before we deal with the bottom. Again, you finish out that answer. Don't forget, feet squared or square feet. Next, a little application. Let's see. A triangle with an area of 45.5 centimeters has a base that measures 14 centimeters long. So what do we got? We got area equals 1/2 times base times height, right? So I just want to get in all the pertinent pieces. Now what? Same thing as before. Substitute what I know. I know that the area is 45.5. So 45.5 is equal to 1/2. And it said it had a base that measures 14 centimeters. And it says to find the height. So I guess that's what I'm missing. Now what? Finish out the algebra. Solve for height. Now again, height is one-dimensional. There's only one way you can measure height, right? So it's not going to be square units this time. It's just going to be something centimeters. But you finish this problem. 16. Find the length, right? So apparently we don't know the length, right? So length is our question mark. Of the second base, sounds like we're heading into trapezoids. That's the only one I know that has multiple bases. The second base of a trapezoid with one base measuring 12 feet, height of 4, an area of 58 square feet. So again, trapezoid, 1/2 times open parentheses base 1 plus base 2 times height. Now let's substitute in the pertinent information. Area equals, it says find the length of the second base with the base of the one base measuring 12 feet plus, I don't know, close, height of 4, and I guess I can scrap the area and I can put in the value, that is 58 square feet. Okay, now what? Now this one I'll take you through the algebra a little bit. First off, I have this sort of A times B times C scenario here. So couldn't I multiply A times C first? Can't I multiply 1/2 times 4 and say that this is 58 equals 12 plus x in parentheses times 2? Isn't that half of 4? Sure. And now, can't I take the 2 and divide that on both sides? And of course, I'm being rhetorical. Of course I can. So 29 equals, the 2's cancel out, and I'm left with 12 plus x. And now you can go ahead and finish that. And remember, this is a one-dimensional answer again. So we're talking about the second base in terms of feet. So it's just feet, not square feet. You finish that one. And like I said, we're covering a lot of ground today because really all this area business really is stuff that you should have covered in middle school. If not, I'll apologize for the speed, but it's just some basic stuff that we're just kind of recovering. So we want to think of the sector, right? This piece right here. The sector of a circle is really just the section, right? Or a portion of a circle that's bounded by the central angle. Now, this is new business. And it's intercepted arc. So what are we talking about? We're talking about the central angle and the intercepted arc, right? And what does it look like? It looks like a slice of pizza. And who doesn't love pizza, right? I love geometry and I love pizza. It's a win-win. Now you're going to recognize the area of a sector formula. It looks very similar to something we had a while back. The area is going to just be the area of the whole circle. And it's going to be multiplied times the ratio of that central angle over 360. Or really, the area of the sector is just the proportion of the circle that it occupies. So we figure out the ratio, multiply it by the area of the whole show, and there you go. Keep in mind that the value of x is the degree measure of the arc, which is right there. Let's get to it. So again, I see that this is a circle and looks like we're dealing with a pizza slice. So I think, this is area is equal to x over 360 times pi r squared. Okay. We're looking for the area, and x is going to be the measure of that arc, the angle, central angle. That's 51 over 360. Now, if you take 51 and you divide it by 360, I get 0.142. So really, it's like 14% of the area of the circle is what that sector is, right? That's what we're really thinking about. Times pi r squared, where this is the radius, or this is the radius. They said that BC, right here, this length, BC, is 16 feet. So that's going to be 16 is our radius squared. The rest of this is just doing some calculator button pushing. So you figure it out, and that's going to be back to two-dimensional square feet. So now we complicate things a little bit. And what do I notice? I notice that I have two diameters, making this a vertical angle, which means that this angle right here is also 113 degrees, which means that this arc and this arc are the same. So the area of sector 1 is the same as area of sector 2. So first we're going to say area is equal to x over 360 times pi r squared. And really we're going to take this answer and we're going to double it because there's two of them. So let's get into it. We're going to say area is equal to, the central angle is 113 over 360 times pi times radius. It says that xy is 30 feet. That's from here all the way to y. So that's our diameter. So radius is equal to half of that, which is 15 feet. So pi r squared then would be 15 squared. And remember, we're going to take this answer and we're going to double it. So the final area is going to be something with square feet. You finish. Number 16, a little bit more complicated. For one, I don't see any diameters, right? So I see this this is not a diameter. What I do see is that this sector here is 62 degrees. And I noticed that the arcs are marked congruent, which means that this is 62 degrees and this is 62 degrees. So I take 62 and I multiply it times 3 and I get 186. So this, and this occupies 186 degrees. Well, I know the whole show is 360, so I subtract 186 from that and I get 174. This 1, 2, and 3, those three sectors occupy 174 degrees. Well, how about if I divide by 3? Or I can just sort of treat it as one sector. So let's kind of tinker around with this both ways. If I treat it as one sector, then that's going to be area equals 174 over 360 times the radius squared, or pi radius squared, I should say, pi r squared. So PC is right here. I just want to see if that's our radius. It is. So this is equal to my radius. So times 12 squared. Now let's do this one out together. Press pause and get a value. And then put your final answer when you're ready and compare it to mine. So I get 218.54 centimeters squared. Now keep in mind, I used 3.14 as an approximation for pi. If you use the pi key, you might have a slightly different answer. I think if you use the pi key, you're going to get 218.65 centimeters. Okay, now what if we treated the 174 and we divided by 3? When I divide 174 by 3, I get 58. So I get area equals 58 over 360 times pi times the radius squared. And then I'm going to take that answer and I'm going to triple it. So I'm going to leave the 3 on the outside and see what I get on the inside first. And I get roughly 72.848. And that's again using 3.14 for pi. And when I triple that answer, I get, you guessed it, 218.544 centimeters squared. So either way, same answer. Depends how you want to treat this. You're going to have to think, and that's going to hurt a bit. I think this slide speaks for itself.